Hello guys, and today I'm going to be explaining what a perceptron is. So firstly, what is a perceptron? A perceptron is a very fundamental neural network concept. It kind of acts as the computer version of a small little brain neuron. The most simplest way you can look at a perceptron is with this structure right over here, where it has three different input values. These values will then be summarized, and then there's a step function, which basically either chooses the output to be 1 or 0, and then it gives out the output. So how is this connected to a neural network? Well, a neural network has many of these perceptrons combined with each other, and each perceptron is basically guessing something from the data set. So for example, let's say you're trying to look up a picture of an apple. In this 2x4 neural network right over here, we will have each perceptron basically modifying its guess rate about how much it thinks it's an apple or not. But the thing about it, in the end, it still has to return a value where no matter how much float numbers and how unsure it is, or how it's let's say it's 98% sure, 80% sure it's an apple, it has to in the end say that it's an apple. It can't just say that oh well, maybe it's an apple, or wait, maybe it's not an apple. You have to give, we want the network we want the neural network to give a concrete answer, oh yeah, this is an apple or this is not an apple. And then we also want to see if it got it right or if it didn't got it right. And this is this is in terms of machine learning with supervised learning. Supervised learning meaning that we are constantly checking the network, and we're if it outputs if it gives us a wrong answer, we will tell the neural network to say, hey, you got it wrong. We next time, make sure you get it right. So we're gonna change the weights. So we're gonna change the weights of the perceptron to make sure that it adjusts to our data set and adjusts its chance to predict better. We're basically essentially training this perceptron to correctly guess the data it's been given, the data being these three x's. We are not going to go into these deep neural networks with many different layers and stuff like that. We're just going to look at the very fundamental beneath it all, and it's this little perceptron right over here. So here's an example of what type of data set we can use these perceptrons on. We have this exam type exercise right over here. And I'm gonna read it out loud, everything for you, so you kind of understand what we're getting into. We have introduction. The goals of this week exercise is to get familiar with the perceptron classifier. The set has two parts. The first part does not involve programming or Python. The questions in this part are the type of questions you will meet at the exam. They can and should be solved by pen and paper or a word processor and eventually a calculator. The second part involves implementation in Python. And then we have exercise number 1. You want to predict if movies will be profitable based on their screenplays. You hire 2 critics, A and B, to read a script you have and rate it on a scale of 1 to 6. The critics are not perfect. Here are 5 data points, including the critics' scores and the performance of the movie. So here we have the list of movies, 1, 2, 3, 4, 5. And here we have what the critics gave. So Alice gave a 1, Bob gave a 1. And was the movie profitable? No, it wasn't. Alice gave a 4. In the next movie, Alice gave a 4, Bob gave a 3. Was the movie profitable? Yes. I think you get the gist. Alice gave 3, Bob gave 5. It was profitable, and so on. The question in this exercise is basically asking, is the data linearly separable? Plot the data on a sheet of paper, label profitable movies with plus and non-profitable movies with X, and determine if the data are linearly separable. So here is what I basically did. There are 5 movies, and here we have 5 data points for our movies. So you can see Alice rated it 1, Bob rated it 1. Here we have the Bob rating axis. Here we have the Alice rating axis. So the movies that Alice will rate from 1 to 6, and the movies that Bob will rate from 1 to 6. So you can see here is 1, So Bob rated a movie 1 and Alice rated a movie 1, and it was a failure, so we cross it. And that's basically equivalent of this one. It wasn't profitable. And the same goes for the rest. Here Alice rated 4 and Bob rated 3, and it was profitable. Here we have the same thing. Alice rates 4, Bob rated 3, and it was profitable, yes. And so you can see we have essentially plotted these data points into this graph. And now they're asking us, is the data linearly separable? And I asked the teacher if there is like a function or something that I don't know to calculate if the data is linearly separable or not. But he told me that what I did is correct, and this is completely fine to do. So what I basically looked at, I was like, yeah, you could draw like a straight line that separates all these all these profitable movies with all the unprofitable movies. And that's what makes it linearly separable. Knowing the basics of this, we can start understanding where does this perceptron that I was talking about in the beginning come in here. I'm gonna read out loud exercise 2 now. You decide to use a perceptron to classify your data. Suppose you directly use the scores given above as features, x equals score given by A, and x given and x2, where x1 equals score given by A, and x2 is given a score is given by B. You can also add a bias term in the position 0, x0 equals -1. We will continue reading before explaining everything. Run one pass through the data with a perceptron algorithm, filling out the table below. Go through the data points in order, e.g. finding data from movie 1 and step 1. Suppose we start at the weights, weight 0, weight 1, weight 2, equals 1, 0, 0. Use 1 as a learning rate. For each of the 5 steps, write a score and whether the prediction is correct. Calculate the new weights, enter them at the line, and repeat. This was very confusing when I first read it, so don't worry if you kind of basically do not understand what the hell they want from this, because I didn't either. But looking at this, they have like a formula and they have weights here, and the prediction is correct, right? If we look back at our perceptrons, these are the weights we're technically inputting. So in our perceptron, weight 1, or weight 0, I'm pretty sure it's called, and they define it as weight 0. Weight 1, weight 2. And so all these weights become summarized. This sigma means that we just sum it all. It just basically means sum. We add all of these together. And then we have a step function, which usually is just written by this. These step functions can be different, but I'm going to also explain what a step function is. And then in the end, we will get the output. So in our case scenario, we set our weights. They set our weights to, in our example, they set the weights to 1, 0, 0. So this weight is 1, this one is 0, and this one is 0. And so our sum function is going to be the weight times, we're looking at it for the first movie. So for the first step, which means that we're going through the first movie. So you see Alice, they said it here. Alice is x1 and Bob is x2. So mathematically, we can have a mathematical notation here where we do W0 will be times. We're doing a times here. We just don't need to write it mathematically. So I'm just writing it like this. And then we do plus. And then we have the first weight times Alice. And then we have the second weight times the Bob. And in our scenario, you might be wondering, well, what is the 0, right? 0 is the bias. You can also add a bias term in position 0. So x0 will be -1. So in this case, as they say, our 0 will be, we will multiply it by -1 because that's our bias. And we can also use this. Oops, we can also use these parentheses. There we go. We can also use parentheses to count as multiplication. So we just put it in parentheses, and then we do addition. And then you can see this weight is 0. And then we multiply this. I mean, might be, let me look at the cheat sheet. How did they do it? Yeah, okay, they actually do times everything here. Yeah, I mean, we can also do that. We can do times here. Times Alice's first score on the first movie, which is 1. And we do times 0 because that's our weight, or plus 0 times Bob's movie score, which is 1. And so what will this equal? So 0, anything multiplied with 0 is just going to be 0. 1 multiplied with -1 is going to be -1. So in the end, we will just get -1. And the -1 is actually going to go through a step function. And step function is basically makes it so that the data can either be 1, 0, and in some cases they do -1, but usually it's 1 or 0. And it depends also on the function that you're using, right? So this right over here, you just gotta, sadly to say it, mathematicians, you just gotta memorize this step function. But honestly, the step function makes a lot of sense. It's very easy to do. The function that we will use, very common in perceptrons. I don't necessarily say that this is an absolute rule, but it's one of the most common functions in that is used in perceptrons is the sine function. And the sine function is also also known as the sine num function. Here is the Wikipedia page for this function. The most important thing to see here is that it can only output 3 values. It can output -1, it can output +1, or it can output 0. And that's exactly what we need. We need either 1, -1, or 0, right? What we have calculated, let's say that right now we're very lucky that what we have calculated is -1. So it's pretty close to the output. But so the sine function kind of almost doesn't really do anything, right? You just output it as -1 because we already got a -1. But if we would have, for some reason, we would have instead had like 55, or like a very huge number, like 5,500 or something, right? What the sine function would do is it would return the closest number to the input. So we input 5,555, it's going to return 1, because that's because it's above 1, it's a positive number. That means it will return 1. Meanwhile, if we had our function had like -55, what would it return? It would return -1, and it would return 0 if the input itself is also 0. So if what we would have here would have been 0 and we put that into the signum function, it would give us 0. But here we input into the signum function -1 and we will return -1. So as you can see, it's just a very quick way to make all of this big calculation a very like coherent number. Like it could either be 1 or -1. Or in some cases, it can be 0, but we don't necessarily have to use it, because the only times it can be 0 is, yes, if your weights are set to 0. So as you can see in practice, you never set your weights to 0. So in practice, you would either have a 1 or a -1. Now we can put in the data right over here, and you can see this, exactly what we wrote here, is written in here. It will equals -1. And -1 for us, we say that it's not profitable. So right now, our perceptron, or small little neutron, or whatever you want to call it, our one little neural said that it's a -1, right? And did the neural predict correctly? Like, was it not profitable? Yes. So it's correct prediction. And when it's the correct prediction, we actually do not update these values. We do not need to update these value numbers. I made a little bit easier way to look at it. We move on to the next. Step, right? And because it's the correct prediction, we do not do anything with the data. We do not do anything with the weights. We still keep it 1, 0, 0. And it will then do the next prediction, right? The next prediction. What's our next prediction? Let's see. Our next prediction is the second movie, where Alice said that it was 3, and Bob said that. Oh my god. Is our second prediction, where Alice said that it was 4, and Bob said that it was 3. And was it profitable? Yes, it was profitable. So here we do the exact same mathematical formula. We can go over it again for our sake. So now, instead of it being 1, 1, we're gonna be looking at the profitable one, which is 4, 3, 4, and 3. This one, exact one on the graph, is just a different way of looking at it. Like, you can either look at it this way or this way. It's just a different way of visualizing data. It's the same. So now we're gonna look at this one, which is 4 and 3. So Alice guessed 4. What do we need to do? We remove this one. We put in a 4 instead, and we remove this one, and we put in what Bob's input is, which was 3. And now, what is the output? It's actually, because we're still multiplying by zeros, we're just gonna get -1. The -1 is gonna go through this signum function, and what's the closest number to these 3 numbers is -1. Then it's gonna output -1, right? And that's what we get here. And the -1, what's -1 in our what does -1 mean in this scenario? Well, it means that it's not profitable. And is that actually correct? No, the movie was actually profitable, so it guessed it wrong. And here is where, when our small little perceptron guesses something wrong, we have to update its weights. So it can make a different kind of prediction that could be more correct, right? And this is essentially the training phase. This is like where we're training our small little perceptron on this data that I'm showing right now. And so how do we update these weights? And I also had a very hard time understanding how to update these weights and what do you need to do and stuff like that. And essentially, it's just a mathematical function you have to know. And it might be a bit like complicated, or it might be very scary for people who are not that familiar in math looking at it. It might be like, oh, whoa, this is crazy. But trust me, guys, we can get through this together. So when it makes an incorrect prediction, that's when we're gonna update this perceptron's weights. And we are gonna, the rule of updating its weights is we take the weight, And the new weight is going to be the weight plus this very curvy n, and which is going to be the learning rate. And these y, oh my god, I'm drawing so ugly. Okay, y and minus y. So, and times it by the corresponding feature value. So this might look very, very menacing. Like, what the hell is going on here? Here we are introducing 3 new things. N, this n right over here, is the learning rate. So what does learning rate mean? It means how, at the rate which the perceptron learns. And you can see you yourself can choose the learning rate in the perceptron. In this example, they clearly specify that you use 1 as learning rate. So what will happen if we use 1 as learning rate? We will come to that. So here's our 1. So here's our 1. So this is very simply, yeah. And again, now these y's, what do these y's mean, right? And so y, the first y, actually is the true label. So the true label, meaning what is the correct prediction? What is the actual prediction? So in our case, we had -1, and it was incorrect. So the true prediction, the correct prediction, would be 1, right? So that's our correct, that's like the true prediction. Like that's what we call the true label, right? And you might also, by deducing this, guess that y with this sign, sorry, I do not know mathematical terminology, but y with this with the sign on top of it is our actual input. So what our perceptron predicted, what came out of this sigmund function, what came out as this output. Well, what came out of it was -1. So, like, in reality, it was -1. Mathematically, if you want to evaluate if the output is correct or not, you can just check if y does not equal our actual output. So if our desired output does not equal this output, then we will perform weight update. And you might be wondering, well, what are these i's? Well, i's is just kind of like incremental, right? So it basically means if you like know about a for loop, we're basically doing like exactly what it is, a for loop through all of these weights. So we do weight 0, this I is going to be replaced with 0, 0, 0. And then we're gonna do this for each weight in this thing. So we're gonna apply this whole function on each of these things, right? And for in our case scenario, let's say, let's start actually doing that. We have weight 0 here. We have weight 0 here. And we have x 0 here, right? And so what does this mean? We can actually look at our cheat sheet, which is our define function right over here. So we do not know what the new weight will be. So let's just say, put it at weight 0 for now. But the W0 is going to be 1. So we're going to plus it with the learning rate, n is the learning rate. And then inside of it, we're going to multiply it with the desired, the real prediction, like what was the correct prediction. The correct prediction was 1, that it is in fact a successful movie, or it is in fact a profitable movie. And then we will minus it with -1, which is what our perceptron gave us, right? Then we will times that with x0, which is the bias, because the first thing is the bias, and that is going to be -1 as well. So as you can see, bunch of ones, so we make it really, really simple. We can calculate this, that this will basically equal, let's see. Okay, firstly, you multiply the 1 inside of these brackets. So you do 1 multiplied by 1 is 1, and 1 multiplied by -1 is -1, so it's not going to change anything. And this minus 1 is going to be plus, so we're going to have 1 plus 1, which is also 2. And then we're going to have 1 plus 2 because of here, and multiplied by -1. And okay, this is like simple rules here. We do PEMDAS, so we do parentheses, exponentials, multiplication, division, addition, and subtraction. And so we do the multiplication here. So 2 multiplied by -1 is going to be -2. So 1 minus 2. And in the end, it's going to be -1. So our bias weight, so our weight number 0, is going to be -1. Boom, simply said. And now we modified our perceptron to actually have -1, right? And now we can do basically the same with the rest. So let's remove all of this, and we're just gonna go through it way faster now. And now we will do it for the second weight. So here's our second weight, weight 1, which weight 1, the new weight 1, because of this thing, this basically means this goes into here. And the weight 1, our previous weight 1 was 0, so we do 0 plus the learning rate, and our learning rate, as we know, is 1. So as you can see, it's just very clearly, if we define the words, they make sense if we understand what these words mean. And y0 is our desired output as well. And -1, right, is our actual predicted output. And now instead of x0, we're gonna have x1, and our x1 here is, in this case, is 4, right? And boom, now we will solve it. 0 plus, do the parentheses inside, and then -1, and then you do the parentheses inside again, which is going to be 2, and then 2, and then times 4, and equals. So guys, 2 times 4 equals 8 plus 0, so it is 8. Very simple mathematics here. And so in the end, our second weight is going to be 8, right? We can put -1 here so it's easier to understand. Oh, no, never mind. That's actually not correct then. So we will remove the 0. It's going to be 8. And if you guys really want, you can guess what the next thing will be. Now we just move everything with 2. And with 2, you know what it is. It's the second weight, which was 0, and the input from Bob, which was 3. And so we do the same thing all over again. these things can stay the same because they don't change. The only things that change is these two values. So we can just remove these two values and put in the W2 in here, which was 0. I removed it. I'm sorry about that. Let's keep it there just for now. And so we put in the 0, and then we put in the x2, which is going to be 3. Yep. And now we can just go ahead and solve it. This output will pretty much be the same. So I'm just basically cheating a little bit here. That instead of multiplying it by 4, we multiply it by 3. And now we're gonna get 6. And with the 6, we will put it in the second weight. And now we have the new weights for our output. So our next prediction, as you can see, our new weights for the new output will be -1. The other output will be 8. And then we will have 6, right? And so what will our scores be now? Well, if you remember our formula, it's this. So it's weights. It's the weights of the perceptrons times the what did the book, or what does the book call it here? Times the score given by B, score given by A, and the last one is the first one. The first one is the bias, which is -1. So again, we will have the weight, which is going to be -1, times the bias. Then we're going to do plus 8 times oh, okay. I forgot to tell you about it. Now, because it moves to the third step, it moves the third step, it moves to the third movie. And here in the third movie, we have Alice rates it as 3, Bob rates it as 5, and is it profitable? Yes, it is profitable. So we do Alice first, and then we do the weight, which is 6, and then we do times what Bob rates it, and what Bob rates it, we can check again. Bob rates it as 5. And this requires just a calculator. Actually, you can just put this in here. I'm pretty sure, yeah. You can just put this one in here. So you can see we will get 55 as a result. And then that 55, what did we learn? That there's also this step function, which basically evaluates it into either these 3 outputs. And because it's 55, what's the closest output it could go into? Well, it can go into 1, and so it becomes 1, right? So the 55 will then become 1, and we will get 1 as an output. So what we will have is then 1, I guess. Like we should have had one more column, which would be like the actual output, but we can just write it as 1 here. It really depends if like the evaluator understands this or not. Is 1 the correct prediction? What was 1, guys? 1 was that it was profitable, right? And -1 on the other side, it's not profitable, right? And is it profitable? Let's look at it. Yes, the reality is that it's profitable. And yes, what do we do when it's profitable and it gets, And what do we do when it guessed correctly? We do not change the value of the weights. So the value of the weights stays completely the same. And I'm thinking you get the memo by now. -1, the weight, this weight, times the bias, plus, let's see, plus 5, because now we're moving on to step 4. Yep, this is the 4th step. So now we're gonna have 8 times 5 plus 6 times what Bob guessed. Oops. What Bob guessed, which is 6. Yep. So 6 times 6. Right? Yeah. And yeah, it was profitable. And we put it in the calculator. We're gonna get 77. We get 77. Again, guys, what do? We put it through the signum function, the step function, which evaluates it the closest to these 3 values, and the closest to these 3 values is 1, and so we will output 1. And so we will output it as 1, right? If it was, again, if this was a negative number, it would be -1. Simple as that. Our prediction here is that it predicted that this movie will sell. And will this movie actually sell? Let's see. Yes, this movie is profitable indeed. Then yes, nothing we need to do, right? This is what supervised learning essentially is. The thing about it is that this is just a small little calculation that we do on this small little perceptron. In a big neural network, we have many of these. So you can see how complicated this might get the more we add, the more perceptrons like this we add. Because then we will have many different perceptrons. You know, we can add more weights. That's one thing we can do. But that's not even it. We can add perceptrons on top of each other, right? That, as you can see, like, what's the reasoning behind this? Now that we have gone through all of these calculations, well, it's to have each perceptron fine-tuned a little bit differently than the other perceptron, which gives us variance in the data, which means that we can look at the majority of things, right? This perceptron might predict that the movie will sell. This perceptron might predict that the movie will not sell. This perception might predict that the movie will sell. And this perception might also predict that the movie will sell. We're basically going through a lot of these more predictions to get an even more sophisticated result, right? And all of these calculations that this big network is performing, it's exactly these calculations that we have talked about today. And again, because it's the correct prediction, what will it do? It will not change its weights because it predicted correctly, right? I can leave you guys with a homework of what would the score value here be, and will it be the correct prediction or not? Boom. You guys can put it down in the comments down below and see it for yourself. But yeah, this was quick introductions on the mathematics behind these perceptors, and how we use them, and how you can visualize the data that these perceptors use differently. As we can see, we could either visualize the data on a table like this. We could have actually also visualized the data like a graph, and this is really important later down the line, when you will learn about more different types of methods that you can use for machine learning. Thank you everybody for watching. Hope you had a great time, and goodbye.